Hi there, welcome to part two. As we move on here, there's something I forgot to say that I wish I would have said at the beginning, but this problem is actually in your book on page 524, and it's example number two. It's a word problem, but I took the equation from there, and they show the problem and work it out there as well. And so you have something there you can look back at if you'd like to review that problem. The next thing I'd like to say is you can't give up on this now. You can't stop now because once you start to see these patterns, it actually becomes easier, a much easier way to factor. So you want to use this lesson to begin to try to recognize these patterns that we're describing. So let's do another one like number one for number two. Okay, number two, here's the one we will try. We'll try 16x squared minus 72x plus 81. All right, we'll talk through it again. If it's not clicking, maybe you see it. Number one, we're going to look for a greatest common factor. Well, I don't see one here. 16, 72, 81. There is nothing there that works. Next thing we're going to do is look for one of these patterns, a perfect trinomial square or a difference of squares. I know it's not a difference of two squares because there's three terms. If it's a difference of squares, that middle term really would be 0, so it's not there. So let's look to see if it's a perfect trinomial square. If it's a perfect trinomial square, again, it means, well, I guess that would be a minus sign in this case. If it's a perfect trinomial square, it would match this pattern a squared minus 2ab plus b squared. So that means that this term a and this term b are perfect squares. Well, let's look at number one, 16. I know 16 is a perfect square, so the square root of 16x squared is equal to 4x. So that would be a. So far it could be. Let's check the second term. Let's check that b squared, 81. Is that a perfect square? Yes, it is. It's probably going to be since this is today's lesson. So that's b. 9 is b. All right, so the question I have to answer is 2 times a times b equal to 72? Let's look and see. I'll just expand it up here. Okay, 16x squared, that's the same thing as 4x quantity squared. 81 is the same thing as 9 squared, and that's a plus sign. So I want to know, is 72 the same thing, that's a minus sign because of that, is that the same thing as 2, following this pattern right here? Okay, if a is 4, here's a, 2 times 4x, this is b, times 9. Is that equal to 72? Well, let's see. 2 times 4 is 8. 8 times 9 is 72. X, 72x. Yes, it is. Therefore, this is a perfect trinomial square. So since it's a perfect trinomial square, if you go back to the top of your page, we're going to use this pattern right here. A squared minus 2ab plus b squared, parentheses ab, ab. There it is. All right, so this is really easy to factor. Look at that. A is 4x minus, because that's a minus sign, 9, put that quantity squared. And that's the answer. And you can multiply it back. You want to check it? You should. If you check it, you go 4x minus 9 times 4x minus 9. All right, you're going to get 16x squared minus 36x minus 36x, right? 36, 36. Negative 9 times negative 9 is plus 81. And I can't write, plus 81. There's your minus 72x. There's 81. 16x squared. There's your check. Because that's exactly what we started with right there. So it's simple. Once you start to see the patterns, or at least know how to check it, you can save yourself actually a lot of time. Really, you don't even have to show me this middle step. When you recognize it's a perfect trinomial square, you can just write down the answer. There's no work to show when you see that pattern. Let's look at another one now. We've got a few more examples we do need to work through. 16x squared minus 81. All right, number one. Greatest common factor? Nope. Don't see one there. No common factors. Special cases. Well, it's not a perfect trinomial square because there's only two terms. A trinomial square has to have 3. But it could be a difference of two squares. It's a difference. The subtraction signs, it's a difference. So what I want to know, are those two numbers perfect squares? Well, you probably already see it, but just for the sake of our notes, square root of 16x squared is 4x, and the square root of 81 is 9. So there it is. So if I know that a squared minus b squared is equal to a minus b times a plus b, well, 4x is a, whoops, that's supposed to be an arrow. 4x is a, 9 is b. The answer is a, which is 4x, minus b, which is 9, times a plus b. And there you go. Nice and easy for you. No box needed. If you want to do the box, you would have to use 0x as that middle term, and then multiply 16 times 81, find terms that factors of whatever that number is, factors of that add up to 0. And this is a lot faster, a lot easier. All right, number 4, let's look at another one. I'm going to throw you a curveball here, but we will work through it. Watch this, 24x squared minus 6. This is actually in your book as well. This is on page 526, number 5. I think they used a different variable. I think they used g, and I forgot the squared. It's 24x squared minus 6. I think they used g in theirs. Doesn't matter, it's the same thing. All right. Uh-oh. These are not perfect squares. But let's see if there is a greatest common factor to factor out. What's the largest number that will go in? They're both even, so I know 2 will go in there. So I know there is a greatest common factor. But there's a larger one than 2. Do you see it? It is 6. 6 will go into both of those. So I'm going to divide out 6. 24 divided by 6 is 4. 4x squared. Minus 6 divided by 6 is 1. Okay, look what I have now. I have 6 times 4x squared minus 1. Now I have to look at this and consider if it's a perfect square. All right, let's look at it and see. I've got 4x squared. That's 2x. I've got square root of 1 is 1. It is. So I need to factor that as a difference of two squares. Difference of two squares factors into a, which is 2x, minus b times a plus b, which is 1. I almost wrote b there. It's really 1 in this case. B is 1. So there we go. Guess what? That's the answer. Look how easy that was. All right, number 5, real quick. We'll get these done. 81x squared minus 90x plus 25. All right, there's not a greatest common factor. It is a special case. It is a perfect trinomial square. Why? Because that's square root 9x squared. That square root is 5 squared. 90x multiplies to 2 times 9x times 5. 5 times 2 is 10. 10 times 9 is 90x. So that means this factors to 9x minus 5 quantity squared. So simple. So simple when you start to see those patterns. All right, let's do one more here and we'll be done. I can't believe we got this done in 2 videos, but here we go. 80x squared minus 45. Neither of them are perfect squares. There's not a common factor. Oh, yes, there is. Yes, there is. Yes, there is. 5, right? 5. 5 will divide out of both of them. 5 goes into 80 16 times. 45 divided by 5 is 9. All right, look, perfect square, difference. You've got a difference of two squares right there. This one, so I don't need that. Use my difference of two squares pattern. The square root of that is 4x minus the square root of 9 is 3 times 4x plus 3. Voila. Look how easy that is to factor. Okay, that's it. Looking for special factors, special cases. If you have a special case, factor it out. If you don't, you'll have to use an old-fashioned method, and that takes care of factoring special cases. And we will see you tomorrow.